This next problem, we're having a 12.8 gram sample of KCl dissolving in 75 grams of water. So let's start out by writing out our variables. We'll have the mass of the KCl and the mass of the water, adding up to get our total mass. So let's go ahead and substitute in those values. 12.8 grams of KCl, 75.0 grams of water. So when we add those two up, it gives us about 87.8 grams total of our solution. We know that our value of C can be generalized to the specific heat of liquid water because most of our solution is in fact liquid water, 4.184 joules per gram degree Celsius. And then our delta T is going to be our final temperature minus our initial temperature, which will give us our change in temperature. So our final temperature is actually 21.6 degrees, and our initial temperature is the 31.0 degrees Celsius. So the temperature is actually going down here. The sample is dropping in temperature. The surroundings are, which means that this is an endothermic reaction happening, or an endothermic dissolving process, because it's lowering the temperature. Our delta T we can get by just subtracting. The final minus initial gives us negative 9.4 degrees Celsius. And so now we just need to substitute into Q equals MC delta T. So here we go. Let's see, Q equals 87.8 grams times C, 4.184 joules per gram degree Celsius, times our delta T, which is negative 9.4 degrees Celsius. So if we go ahead and solve this, our units of Celsius and our units of grams are going to cancel, and we'll just be left with joules. When we solve this, we get negative 3453.1388. But of course, this is in joules. We need kilojoules, so I'll go ahead and convert joules to kilojoules. 1 kilojoule is equal to 1,000 joules. Not clear that was kilojoules right away. And so when we divide this, we get negative 3.4531 kilojoules. Now the problem asks us to find the number of kilojoules per mole, and we don't yet have the moles of KCl that were dissolved, so we need to convert that 12.8 grams of KCl to moles of KCl. So we'll just do a simple gram to mole conversion here. 1 mole of KCl is about 74.55 grams. You can add that up by just adding the mass of potassium to the mass of chlorine. So when we solve this, 12.8 divided by 74.55, that gets us 0.17166968. It's a big long decimal, but we do want to hold on to decimal places because this is not our final answer. To get our final answer, we'll simply take the number of kilojoules, so 3.4531 kilojoules divided by the number of moles, 0.1716968. And I'm actually going to use the full value in my calculator there. And when we divide that out, we get negative 20.111836 kilojoules per mole. We do need to round this answer to sig figs, and we also need to consider the sign on our answer. So first of all, our answer should have 3 sig figs, so we should write our final answer as 20.1 kilojoules per mole. But also, this is an endothermic process. Our temperature in the surroundings dropped because the process of dissolving takes in energy, it lowers the surrounding temperature. So an endothermic process has a positive delta H sign. So this should be a positive 20.1 delta H value. I'll box in this final answer here, and there we have it.